Hi, I'm Bob. Welcome back to 5 Minute Econometrics. We just learned that if the variance of the error term is not constant, the usual standard errors and t-statistics will not be valid. Today, we will explore how to adjust the standard errors and the t-statistics to make them valid in the presence of heteroskedasticity. It is called the Heteroskedasticity-Robust Standard Error, or just Robust Standard Error. It applies to the cases when we do not know the form of the variance of the error term. In the presence of heteroskedasticity of unknown form, the robust standard errors and the robust t-statistics will be valid in statistical inference. Let us use a simple regression with one explanatory variable as an example to derive the heteroskedasticity-robust variance and standard error for the OLS slope estimator beta 1 hat. Suppose the fifth Gauss-Markov assumption, homoskedasticity, does not hold. The error variance can be expressed as sigma I squared, where the subscript I indicates that the variance of the error term depends on the specific value of xi. We first write down the OLS formula. Then we replace the outcome variable with its expression and simplify it into two terms. The first term, beta 1, is the population parameter, and the second term contains the error term mu I. Next, we take the variance of beta 1 hat conditional on x. Since the parameter is a constant, its variance is 0. We focus on the second term. If the error variance is a constant, sigma squared, then we have the variance of the OLS estimate under homoskedasticity. If heteroskedasticity is present, we use the residuals, mu I hat, to estimate the error variances. It can be computed after the OLS regression. The above is the case of simple regression. In a multiple regression, the variance of the estimate for xj, beta j hat has a similar structure. The residuals from the regression of xj on all other explanatory variables play an important role in estimating the variance of OLS estimates. We can also simplify it under homoskedasticity. It leads to the familiar formula. The square root of the variance is called the Heteroskedasticity-Robust Standard Error for beta j hat. It can be used to construct the heteroskedasticity-robust t-statistic. The only difference between the robust and the usual t-statistics is whether we use the robust or the usual standard error for the estimate. Let us examine this model, which we have used many times before. It relates workers' hourly wages to their educational attainments, ages, marital status, and self-reported health status. In Stata, we use the regress command to obtain the OLS estimates and their usual standard errors. We can use the variance-covariance option VCE to specify the type of the variance-covariance matrix. When we choose the robust type, we have the robust standard errors and t-statistics for the OLS estimates. The robust standard errors are similar to the usual standard errors. We can store the results and compare them using the stab command. The t-statistics are inside the parentheses by default. The robust t-statistics are very close to the usual t-statistics, so that the statistical significance of each explanatory variable remains the same. We can always use the Heteroskedasticity-Robust Standard Errors and the robust t-statistics to perform a t-test for the significance of the variables. We do not need to know the form of the variance of the error term. We do not even need to know whether the error term is homoskedastic or heteroskedastic. The robust standard errors and the robust t-statistics are valid in statistical inference, at least in large samples. Thank you so much for watching this video. See you soon. Take care. Thank you for watching this video and subscribing to my YouTube channel. See you next time.